Can you build full mixed reality and virtual reality applications with Android Studio and Kotlin as a programming language? Well, absolutely. And in today's video, we will look at how we can use Spatial SDK to do so. First, Spatial SDK provides you with a set of tools to build XR applications with ease. This means we can set up our environments by using the Meta Spatial Editor, which allows you to add 2D panels, primitive shapes, custom 3D models, and even use a library of models available with this tool. Also, Spatial SDK is architected by using an ECS architecture, so we'll use entities, components, and systems to build our apps, which in simple words, ECS is just a great pattern to keep our code maintainable and also scalable. All right, let me show you what you can build with the Spatial SDK, and we're going to be making also 2 apps by using these tools. So let's jump into my computer and start working on it. All right, guys, so let's get started by cloning this Spatial SDK GitHub repo, which provides us with a variety of showcases and samples that we can use for our apps. One of the showcases included is the Focus application, which features the use of 2D panels for browser windows, a fully working virtual keyboard, controller ray grab interactions, and also a fully functional AI assistant, which for some reason I thought it was just a mockup to begin with. You can also add a variety of objects and move multiple objects simultaneously. For this other sample, you can learn how to shoot hoops through physics, set up scene understanding, and add UI button interactions. Okay guys, so the next thing that we're gonna do is we're going to get the tools necessary for today's video, starting with the Meta Spatial Editor. I'm going to get the Mac version, but you also have access to the Windows version. Once you get it set up, go ahead and download Android Studio, which is going to be the IDE that we're going to be using today for coding. Then go ahead and clone the repo that I suggested initially. This is going to include a lot of different examples, and then copy the starter sample and rename it to Perseverance Mission, which is going to be the theme that we're going to be using today. So once you open the project, this is going to be the structure. The activity, I already renamed it to Perseverance Mission Activity. And then if you look at basically the definition of this is all coming from com.meta spatial, which is the toolkit. The structure starts with registering features. You can register MRUK there or other spatial features. We also have the onCreate method, which is going to be called as soon as the current activity is created. And then the load glxf and invoke on completion are really helpful because that's going to happen when the environment gets set up. And by environment, I mean the actual 3D environment. Then the activity scope on the very top is going to be helpful because that's going to allow us to execute a core routine, and we need to do that as a job, so I'll show you that in a minute. On scene ready is also going to get executed. When that gets executed, we can set up basically the space, the lighting environment, the origin, and also the skybox. Register panels is going to be very, very useful for registering your UI, and that's going to be basically 2D panels. And then load glxf, this is what I was talking about. This is what's going to launch the actual core routine. So that composition file, it's what's going to allow us to, basically it's going to be set up in the Spatial Editor. I'm going to show you that as well. So as far as the project structure, I recommend looking at the app and then scene, source, and all the different files that we have in here. Composition, this is going to be related to what we just looked at. Then we have materials, we also have textures, and you can also look at the textures in here that are basically going to be assigned through materials in our environment. So let's just go ahead and close everything. So now these 2 files are going to be used by the Spatial Editor. So let's go ahead and open these right now so that you can see what I'm talking about. So if you click on the library, you can also look at pre-existing 3D models. In my case, I'm going to download the MR headset and also the MR controller right. The reason for that is because I want to show you something pretty quickly on how to get this environment set up. You can enter the translation values, or you can use the gizmos that they provide. If you hit F, it's also going to focus on that object. You can also just change here the Z value, and then we can also clone it. So very similar to other editors such as Blender, Unity, you have a lot of the functionality available. You can also scale. We can also, in this case, if we wanted to change the position of the objects in the hierarchy, we can do that. I call it the hierarchy, but it's basically that UI on the left. And then you can also add different components in here, which in my case, I'm going to add a grabbable so that we can interact with the headset by using our controllers. Then what I recommend doing is copying all the resources from this repo into your project. Then what I'm going to do though is I'm going to go into my UI example and we're going to be assigning the new texture. So I'm just going to make a couple of tweaks so that you can get an idea of how this works. And you can use the hand to basically pan around. I can also resize. Oops, let me go ahead and change that. And then you can also resize the panels in here. Another option that you also have though is you can go into this other view. And what I'm going to do here is I'm just going to make a couple of changes to the UI. Let's go ahead and connect my device via USB-C so that we can start developing. I'm also going to go ahead and select it from Android Studio. Just make sure that you have enabled developer mode on your device. That way the Android Studio is going to be able to recognize it. Then what I'm going to show you though is this is the running experience. I can use my controllers. You can also use locomotion, which is really cool and it works out of the box. No coding necessary to do that. I can also interact with the object that I added as a grabbable by using the Spatial editor. All right, guys, so now let's go ahead and delete the assets that we previously added. I'm going to be adding Mars and also the Perseverance rover for the next app idea that I have for this tutorial. So I'm going to go ahead and just import it. You can just import the files and then rename them. This one, we're going to have to resize it, but we'll do that in just a minute. Then the actual Perseverance rover is also going to be called Scene. Let's go ahead and rename it. Once you have it renamed, you can drag them and drop them into the left UI. And then you're going to see that now we just need to scale it and then position it. Just make sure that you follow the values that I have in here, or you can just change them depending on your likings. So once you do that, we're going to be adding is visible to true. Basically, the component is called visible, and then the property it's going to be is visible. So just set them to true on both of those. Then we can go into the actual planet material, and if you wanted to change the colors or different values in here, you are more than welcome to do that. So we're going to be cloning the panels as well and resizing them. That way we can have different areas that we can play with for this app. The one on the left, which is the one that I'm modifying right now, it's going to have a video. Then the smaller one is going to be basically UI controls. And you also need to change the ID here to point to the right panel that we're going to have associated with the XMLs. So to do that, we need to basically rename our layout to UI main. Then I'm going to just go ahead and change the UI here by just pasting different values. And then you can see here that we have text views. We also have different values that are in red because we haven't really added the actual resource values. So let's create our other UI component here, which is going to be called UI video. This is going to be holding a video from the NASA Perseverance rover mission. And then once you do that, we can basically, we're going to have two items. So one of them is going to be the text view, and the second one is going to be the web view, which is going to be playing the video. Then the next UI, it's going to be for controls. These are going to be things that are going to allow us to toggle whether we want to show Mars or not, whether we want the robot to show, and it's going to also be animated. Then we need to paste all the different values that we're going to be basically using from our UI. This is just something that I wanted to show you because it is recommended as you're doing development. That way you can localize them a lot easier in the future. Then on the UI controls though, we now have the resources, so everything should be properly set up. Then in our activity, we just need to change the register panels. I'm just going to remove things that we don't need and then rename the actual layout name. Then we can just go ahead and clone it multiple times. And the reason for that is because we're going to have videos and we're also going to have controls. So we just need to point each one of the panel registrations to the appropriate IDs. So once you do that, we can go ahead and cast. And then I already deployed the application to my headset. So I'm going to show you here what you can do to test it with the actual Meta Quest Developer Hub. We can see the environment. I'm casting, I'm wearing the headset, and I can rotate my head, right? I can also look at the controllers. Let's put the controllers down, and I'm going to be using the input forwarding features, which is going to allow me to use my keyboard, my mouse, to basically simulate what I would have to do when wearing the device. So this is going to allow you to develop much faster. Okay, so now we're gonna need to play a video within our UI video. So we're gonna be wrapping this code within the panel area. And then once you do that, we're just gonna be basically getting the web view. And the way that we get the web view is we can just make sure that we have the right ID in our XML, and then use our find view by ID, and then just pass in the actual ID. Then this came from one of the examples that the Spatial SDK team has in GitHub. So I'm just basically just using the same code structure. So once you do this, all we need to do is basically load the URL of the video that we're going to be playing. There's also different parameters in here that you can pass. Then for the actual entities, I want to be able to toggle the planet to be visible or not visible. Also the same thing with the rover, the environment, and the skybox. So that's why I have all these entities. Then I also need to keep track of them by using Booleans. So that's why I added those different private variables. Then we just need to refactor this code just to make sure that we're setting the environment variable correctly and it has the right name. So once you do that, you're gonna see that now that looks good. Then we also need to copy the environment. And the reason that I'm doing this is because I want to get the reference to Mars. And then also the same thing for our rover, which is called Perseverance. And you're gonna see though that these names are going to be matching the names that we have in the spatial editor. So that way it's going to be, it's going to be a lot easier to understand. Like if we look at it here, you're gonna see composition matches that, Mars, and then Perseverance is going to be matching. So that's basically what we're getting by writing this code. Then for the skybox, I also need to set our skybox variable before we're gonna be able to implement a day to night or night to daytime toggle. Now we need to create a new function that it's going to basically set up the UI controls. So I'm gonna say find view by ID, pass in the type, and then also the name of the button that I want to get into this variable. Then we can just do these to make sure that we don't really mind about not having nulls. That's what these two exclamation marks are gonna be for. And then we can also toggle the visibility and also set the component. So in this method, I could have set component instead of set components. Just if you wanted to basically set multiple components, that's when you would use the plural version. And then we can now check the visibility state. And depending on the state, we can designate what the value of the button text is going to be. That way we can show the differences in what the user can do. So now let's go ahead and test it. We can see now that we have the video playing, audio is also playing, which is awesome. And then you can also see that the actual planet is currently showing. We also have it set to high Mars on the button, so I can change the visibility as well. We're also going to be refactoring our code, and that way we can use the setup toggle button for multiple different toggles. And it's going to make it a lot easier if we wanted to add more features later on. So this is going to be calling the setup toggle button for the Perseverance. Also, it's going to start the animation on the rover. Then we're going to be setting the same thing for the sky, so we can change it to night or daytime. And also whether we want mixed reality on or off. Okay, so we can also set the grabbable component here in code, which is different to what I did at the beginning, where I did it on the spatial editor. I can also here in the demo turn off the actual virtual reality environment and then go into mixed reality, which is what we added. We also have the rover here animating, which is cool because now our world or environment is starting to come to life. And then we also have our planet here. Okay, so the beauty of using a Spatial SDK is that it decouples a lot of the logic from having everything in one big chunk of code. So what you can do is you can use ECS, right? So we're gonna be adding an ID here, which we're gonna need for a custom component called rotator. This component is going to keep track of the rotation speed. And then we also can use this component to basically rotate any entity, right? This right now, it's just storing data. But if we wanted to act on that data though, we need to create a system. So that's what this rotator system is going to do. The execute is going to be executing, basically think of it as something that executes per frame. And this is similar to the gain loops that you have in Unity or Unreal Engine. The system itself is the one that is going to be acting on the actual entity. So that's what I'm doing here. I'm querying all the rotators, and then I'm looping through each one of those that I find in the scene. And then if I find them, then we can calculate the rotation. Lastly, to apply it, we set our updated pose, set our entity transform, and then pass the transform to our entity. Okay, just as a recap though, we're gonna be calculating delta time, we're going to be creating our query. Once we find those items that match our query, we're gonna be calculating the actual rotation. And lastly, we're going to be applying the transformations. All right, so in order for us to be able to use it, we need to register the custom component. So this is where we're going to be doing that at the end of onCreate. And then we also need to register the custom rotator system that we're going to be using. Now, make sure that you compile your code before you go to the Spatial Editor, and then basically just reopen the Spatial Editor. Once you do that, you're going to be able to apply this custom component. So now let's take a look at what we have here, right? This is no change from the previous version. We still have the robot animating, and you can see the planet is currently rotating, and looks like our rotation system is working correctly. All right, guys, I had a lot of fun testing Spatial SDK, and I'm really curious to hear your thoughts. Let me know in the comments below if you're thinking about using these tools. Also, if you're doing Android development, let me know as well, as this could be a great opportunity for you to start with XR. And lastly, thank you so much for supporting my content by watching this video. If you guys have additional questions, let me know, and happy XR coding, everyone.
There's no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and these science instruments were purposefully selected to help us in the search for bios.
AI built in, running all the core experiences you'd expect, has been something we've been working on for nearly a decade now. Way back then, when we first started this project, the teams crunched the numbers, and they said that they thought our chances